Welcome, everybody, to the weekly Quantum World Detangled, Season 4, Episode 2. I'm joined by my friend and sponsor, Denise Raffner from IonQ, out of a hotel room in where?
I'm in Maryland. It's my first business trip post-COVID. And I need to compliment André on his backdrop. He has an IonQ backdrop. So thank you for that, André. You can see the chain of ions behind him. But happy to be traveling and happy to be going to IonQ today. So it's going to be a good day. And we are joined by Markus Braun from JOS Quantum. So Markus, can you introduce yourself?
Hi everybody, I'm Markus. I'm the founder and managing director of JOS Quantum, a small startup founded in 2018 in Frankfurt am Main, Germany.
My hometown, which is not the main reason that we have you on our little show, but we love Frankfurt, and tonight, obviously, the football match, France-Germany in the Euro 2020, which I'll be watching. Markus will be building quantum technologies. We'll talk about that a little bit. Markus, let's try to get to know you a little bit. And you're one of our guests that has a very light social media and internet footprint, so we'll need to do a little digging here live. You studied physics in Magdeburg. Is Magdeburg your hometown? Where are you from? What's your origin?
So I grew up in a small village in Germany, close to Hanover. So it's very small. There was no bus schedule at all. So there was sometimes coming a bus, sometimes not. That was pretty far gone from the city, so it was quite a ride always to go into the big city. It took me about 2 hours, so I went to Magdeburg to study physics there, and had the chance to work with great professors, great educators to get me into quantum physics especially. So I did my master's degree there in quantum in mathematical physics, so which is basically just physics in Germany, and went into the direction of quantum physics. And I had the chance to go abroad as well for my master's thesis. So I went to Japan for a semester, and after my master's thesis, I went for a couple of months to Taiwan as well to deepen my studies. So this was a great experience and got me even more excited about quantum computing, quantum physics especially. And from this on, I had some kind of a gap year, I would say. So my funding for my PhD was starting a year. I had a 1 year off between my starting of my funding or my grant for university and where I was. So I went into the industry to work a bit on an industry side, so especially in finance. So I went into finance, worked at Deutsche Bank and Commerzbank or other financial institutions as a consultant, and figured out that there was a momentum coming right now in quantum computing. And I was talking to colleagues and talking to more and more people about this topic, and was so excited about what's might happening in the next couple of years. So I was speaking to them, talking about problems in finance, talking about problems we solve or we look at with quantum computers, and I saw a growing match of both of these things, like they were matching and aligning pretty well. So I figured this might be a 1 in a million chance to now go and do the PhD, or just get more people excited about the topic and found a company. So I went with the later one and talked a lot about the opportunities and the possibilities to a couple of colleagues, and they were all excited and said, go for it. And so I went in 2018, especially I went on and founded JOS Quantum, as it were, together with Niklas, my co-managing director. And from this on, we talked with more and more people and Sven joined, another colleague who especially has a great background in quantitative finance. And then we had a lucky chance to meet Thomas Decker in one of our events, and he was just an awesome guy who has a lot of experience in quantum information science. So we really wanted to have him on board, and now he's since 2019 he's on board, and we're really happy to have him. And so we grew our small startup now with just 4 people but we do a lot of great stuff and working on a lot of awesome.
Mostly in financial services, at least that's how you started out. You're one of those quantum tech startups really focused on specific use cases. Denise will dig into that a little bit later, but that might explain why you're based in Frankfurt as well. Currently, and I wrote about that in my newsletter and on social media, Munich and Bavaria seems to be getting much of the attention and love. Germany in general has grown a lot, at least in its perception internationally when it comes to quantum. I think you also run a meetup in Frankfurt. Can you talk a little bit about what you see in Germany outside Munich, outside Bavaria, and especially in Frankfurt and maybe other regions?
So Germany has a great foundational research potential. Like we have a lot of great researchers at universities who are working not just on hardware sides, as well on software sides. And we're working on a lot of different kind of foundational research. That's really a really strong case for Germany in quantum technologies or quantum computing. And we were especially, there are a lot of great groups all over Germany. So we're not having just Munich as one example. There's another kind of region forming in Hannover. There's another region here in Frankfurt, and we have Stuttgart, Karlsruhe, the area. So we have a lot of different places where we really have, and I didn't even Berlin as well. So we have a lot of great research, and I don't want to exclude anybody. So we have a strong foundation. What we're a bit of having a small issue with, or lacking a bit behind, is getting this foundational research into commercial companies, into privately funded companies. And that's why we see that this might be a problem, especially in these deep tech areas like quantum computing is. And more research and more politics go into this issue and trying to fix and trying to get this gap. We're not quite there yet, but we will expand everything in this direction and try to get as many information from the research side out of the lab into the industry. That's basically what the big plan for Germany right now for the next couple of years, I think.
And I had the pleasure of speaking with Prime Minister Bouvier, who runs the state of Hessen, where Frankfurt is located. He has big ambitions, at least that's what he says, in quantum. Hopefully that will come true. Just quantum, and I'll let Denise ask the questions about what you really do. Is it a software company, an algorithmic company? What would you describe it as?
Yeah, so we are working closely with clients from the, as you said, very focused on financial industry, insurance industry, and we got a project in energy as well. And we're really focused on this stream where we have like problems which relate to financial industry problems. And there we work closely with clients, develop algorithms together with them, and building a quantum software. Because at the moment, and you guys know that, quantum computing is still in a very early phase of existence. So we did a lot of research, but there's still quite a long way to go to bring it into full production. So what we do is we need, even as quantum algorithm developer or even as quantum software developer, we need to go very, very low level, even in the hardware stack. So we need to know a bit more about the connectivities, about the sorry, André, was ist Eigenschaften?
Properties.
Yeah. So we need to know a bit more about the properties of the quantum hardware to truly develop a close or near-term algorithm which might be productive usage earlier than later in times of business cycle. So we do that. So we will consider ourselves as a quantum software company, quantum algorithm design company. That's what we basically do, and for the financial industry, for the insurance industry, and for the energy industry.
Well, there are still way too few German quantum tech startups. You're one of the leading ones, if not the leading one, in that space. Let's find out more what it is that you do. Who are your customers? Who are your products? How much have you raised? How much will you be raising? Denise, don't take no for an answer.
Okay. Markus, I realize that I'm normally in Frankfurt every June, so I think it's really timely that you and I guess we're meeting over video this year, but hopefully next year I'll be in Frankfurt in June again.
Yeah, hopefully. Oh, it's great to have you here.
Yeah. So, André, we talked a little bit about JOS Quantum starting in 2018. You guys have progressed with a tremendous scientific team. You just did a great. Maybe you want to talk about your publication with the Deutsche Börse, which was a recently. I know I think I forwarded it on LinkedIn, but I was excited to see that publication. Could you talk for a minute about that recent work that you've done?
Yes, of course. So one of our clients, as you just mentioned, was Deutsche Börse Group, and we looked at a problem together within the sensitivity analysis of business risk. So what we basically have is a model where they try to estimate the business risk or the expected revenue risk from certain external events. So of course, the Deutsche Börse faces risks in various ways. So one example is in business risk. Of course, there are operational risks as well, or market risks. But in this certain project with Deutsche Börse, we looked at the business side of risk and which risk they face within it. And they are external events. So what they're doing is they're looking for risk outside the company which might affect the revenues of Deutsche Börse. This can be regulation, like if a regulation change happens, which strongly affects the operations of Deutsche Börse, which might be political stabilities in certain countries. This might be various reasons, like the COVID pandemic, various reasons which might affect the workings of the group itself. And if we just look at a tiny example of this huge risk which might affect the business, is let's say you have a country X, and there might be a chance that a political crisis occurs. This might lead to a FX volatility increase, or even a rating downgrade in this country, and this might affect the revenue of Deutsche Börse. All these factors, or these three factors, are interconnected. So if a political crisis occurred, this might trigger a FX volatility increase or a rating downgrade. So let's say we have with a 20% chance that the political crisis occurs. This might trigger with a 40% chance a FX volatility increase, or with a 50% voting downgrade. But even though the political crisis did not occur, FX volatility increase and the voting downgrade can occur by itself. So everything what's happening here is a graph which is directed. So we have a network of possibilities of risks which are interconnected with each other. And one risk might trigger another one, but the risk can trigger itself. So this is going to be like a huge graph of different kind of factors, risk events which can happen. So the idea is now, how do we calculate this kind of impacts, and how do we measure the loss or the revenue decrease in Deutsche Börse, at Deutsche Börse Group. And one example is, at first we write all the events on a list. Then we write all the dependencies on a list. And then experts come and give it a percentage of occurring, like of interconnection occurrent. We have a probability of this event happened, and we have different kind of probabilities to all these events and transitions of these events, like the one triggers the other one. And if we have all these kind of probabilities, we can now do so-called Monte Carlo simulations. So we can simulate what happens in certain scenarios, in certain simulations of this graph, like what happens when item 1 triggers item 2 but not item 3, what happens when item 1 triggers and item 3 triggers without that item 2 is triggered, and all these different kind of scenarios we can go through. And you can do that by doing the so-called Monte Carlo simulations. And what we want to then have is some kind of graphical representation of the results, like how many risks have been triggered. This would be like a distribution of which has a certain shape. And what we are interested in this special case, was the events or the happenings, like the simulations, which have a low probability of occurring, but a high impact on the revenues. So the so-called tail events, like on the end of the distribution. And if the model shows that the risk of the tails of the distribution is too high, we have to take action. Risk mitigation have to take place. Like then something needs to change, because the probability that there is a major impact for the operational or for the revenue of Deutsche Börse might be too high. So once you have everything set up and you did your calculation and you triggered it, we are now interested on how might a change in these probabilities change the outlook of our distribution, which we have after our Monte Carlo ones. So what if we're not having a chance for risk item 1 to be 10%, for example, but 11%? So how does this affect our distribution? Might there be a possible way that one parameter is very, very sensitive to the estimates of these distributions, of these risk items? So to do that, you can, of course, just change one parameter, like from 10 to 11%, run your simulations again, then change another parameter, run your simulations again, change another parameter, and so on and so forth. But to run this Monte Carlo simulation, to run the simulations, it takes, as my colleague would say, a good coffee break, an extended coffee break to run it. So you send it to your server or your cluster, and it would take a couple of minutes to run it, and then you come back after your coffee break and you have your solution. So if you do that for, say, hundreds of risk items, of course, you have hundreds of extended coffee breaks in between. This would make the problem pretty infeasible to do it in just basic business processes. So what we did is, and it even gets worse when you look at pairs of inputs or triplets. So if you change pairs and triplets of inputs and then look how this distribution might change. So what we...
Markus, can I interrupt? I'm wondering what the timeline is on this use case. Is it something in implementation, or is it a proof of concept?
So the idea of this use case was to show that there is quantum computing usage within the financial sector. So that the idea of Deutsche Börse was, of course, to get into this field and get to know a couple of interesting things about quantum computing. So we did that by doing exactly this use case, and we run that on so we translated all this, what I explained, into a quantum algorithm. And with the quantum algorithm, we then saw that we can have a decrease in time from years to minutes. So we had around 14 years, as we estimated, for the WIS model as it was running, or as it might have to take for the sensitivity analysis to run. And we would have just minutes with a quantum computer to run the same simulation. And this would make it, of course, way more feasible.
That's exciting. Now, what quantum computing platforms have you guys worked with at JOS?
So, of course, the most available, most publicly announced ones are the ones from IBM, for example, or the ones from Google, and we get the IQM here in Europe. But there are, of course, or as you already said, Denise, the iron-trapped ones as well. So we experiment, of course, with them as well, and looked at our systems or our algorithms, how they would perform on this side, these algorithms or these platforms as well.
And
so we're pretty hardware agnostic on this side. So we're trying to focus. It's
like most software companies, right? How much? I know you guys have had a couple rounds of investment. Do you disclose how much has been invested in the company, or is that confidential?
We're not disclosing. No.
Okay. All right. Next question. So I'm interested, is your model to then develop software like what you did for Deutsche Börse and apply it to other institutions, or what are your next steps after this?
So of course, you can. So the idea behind this quantum is, of course, to develop a software which would help the user, like the end client, the client, to use quantum computing without needing to bother with all the connectivity issues, with the qubits, with the gates, to not extract the user from all of this and have a high-level kind of language to interact with quantum computing. So we're using all this knowledge and all these kind of models to write a library, so to say, of algorithms which can be used without bothering using quantum on qubit level, programming on qubit level.
So what is the next steps for your company? Are you going to build further, or where do you see? I noticed that, you know, when you and I first met, you were focused on finance. And now I see you have other projects in insurance, which is great, because I think that's an industry that there hasn't been a lot of quantum work done in. So congratulations on that. And energy. Where do you see yourself going? Further diversification, further depth in these fields? Can you comment at all on that?
Yeah, so we stay true to ourselves. So we really wanted to focus on these fields, or especially more or less because we come from that finance. So we see there's a lot of similarities between finance and insurance. So this is like a no-brainer for us to include this in our portfolio of verticals, like of business verticals we're using or we're working on. So we of course want to expand within our expertise domain, which is finance, insurance, and energy, and build a software around that. We're not going the full broad approach and say we can do we will have a match for every problem in every industry. So we just say, okay, we know the field, finance, insurance, and energy, we know them pretty well, and we know problems there pretty well, or challenges there pretty well. So we stay inside this verticals.
That makes sense. Well, I'm excited. You guys have done so much in really a short period of time and have such a talented team. So I'm excited to see what comes next. And I'm going to hand it over to André to give you his questionnaire that he gives everybody on this podcast. So good luck.
Thanks a lot, Denise.
The Marcel Bruce Quantum Tech Questionnaire. Markus, actually a quick follow-up question before that. There seems to be a trend that more and more hardware is being purpose-built for specific applications, algorithms, use cases, and more software specifically tuned to hardware. How do you think about that at JOS?
I mean, at the beginning, the first applications will be very, very hardware, close to hardware. So it needs to be specially adjusted for the application. So you need to have the full spectrum from going from the end user application, like from the application in your field, all the way down to the hardware implementation. So you need there at the beginning, there is no software company do X and hardware company do Y, and then we combine it in a certain way. So we need to work closely together in every sense. So this is will be at the beginning, at least, a very, very crucial point to bring the first applications of quantum computing into production.
And I'm sure Germany and Europe will be the source of some announcements and in that respect, hopefully soon. But let's get to the philosophical part and learn more about you. Very short questions and very short one-sentence, one-word answers, true from the heart. So if you're ready, Markus, the Master of Truth, James Lipton, Weekly Quantum World Detangled Quantum Tech Questionnaire. Markus, who is your favorite scientist?
Einstein.
Who's your favorite entrepreneur?
All of them. They're all great.
What is the quality that you desire most in a scientist?
Passion.
And what is it that you appreciate most about working in the field of quantum technologies?
Challenges. I try to answer with one word always.
Very good. I'm not.
You're
You're halfway through. I'm pretty confident you'll get a little lengthier soon. What is your favorite quantum tech application, and potentially also outside quantum computing, and what you guys are specifically doing? Just close your eyes, dream. What would be your favorite application?
I mean, everything quantum computing and finance will create is going to be just awesomely phenomenal for the industry, especially for all the participants, which includes us as retail clients. So everything which will come out of quantum computing combining with finance, especially when quantum computing is ready and in production, this will be very, very interesting.
Spoken like a true Frankfurt banker. From the perspective of humanity, what is your quantum dream?
I mean that all the challenges we currently face in the field might be sometimes demotivating and sometimes for some kind of problematic even in a community sense. So that we face all these challenges together, that we go through it, and then in the end we will be closer together just by the process of developing a fault-tolerant quantum computer.
Which is my last question. Imagine you wake up to a universal fault-tolerant quantum computer in your living room. Who would you give it to? It's the only one in the world.
I would work on it myself. I mean, I would use it myself.
All right. Your intentions have been clearly stated. Markus, it was a pleasure to welcome you and a guest from Frankfurt. Denise, I appreciate you appreciating my background. We need this as a painting or a sculpture. It's actually beautiful, very Miami. I like the shine of it. Thank you, INQ and Denise. Thank you, Markus and JOS Quantum. Check them out online. This concludes Season 4, Episode 2 of the Weekly Quantum World Detangled, and you are now detangled.